let us discuss the histology of the heart wall. The outer aspect is covered by a single layer of squamous epithelium called mesothelium, supported by a thin layer of submesothelial connective tissue. So this is mesothelium. Which is simple squamous epithelium supported by submesothelial connective tissue. Together, this is called serosa. The word mesothelium comes from the fact that embryonically this epithelium differentiates from the mesoderm. Then we got a variable adipose tissue with the peripheral nuclei and vacuole lipids. Also the major coronary blood vessels, so coronary arteries and coronary veins. The veins are usually deformed in histological sections, which is a post-mortem artifact. We can find autonomic nerves there that are regulating and affecting the heart rate and the strength of the muscle, heart muscle contraction, etc. So there is adipose tissue. Major coronary blood vessels, autonomic nerves, everywhere here is usually adipose tissue. Yeah. And this is the layer called epicardium. Then comes the muscle layer, the myocardium. As we already know from the histology of cardiac muscle, there are cardiac myocytes that are slightly branched. They form a three-dimensional network. Each cardiac myocyte has usually a single nucleus in the center. Exceptionally, there might be two. On the poles of the nucleus, there is usually a pigment called lipofuscin. There is the cross striation pattern, because it's sarcomeric muscle. They are the intercalated discs on the contacts between the cardiac myocytes, and the muscle tissue is embedded in a loose reticular connective tissue called endomysium with connective tissue cells and a very rich capillary bed. It's known that every cardiac myocyte has in its vicinity a blood vessel. which is not more distant than like 10 micrometers. So these are cardiac myocytes. There is this lipofuscin pigment. On the poles of the nuclei. There are intercalated discs between cardiac myocytes. With cell junctions responsible for mechanical cohesion among the cells. That's fascia adherens, desmosomes. And also there are cell junctions that electrically connect the sarcoplasms of the adjacent cardiac myocytes, which are the gap junctions. And there is this rich capillary network in the connective tissue called endomysium. In endomysium connective tissue. This myocardium layer might be very thick. It's much thicker in ventricles than in the atria, and postnatally it's much thicker in the left ventricle than in the right ventricle. So here it would continue. It's called myocardium. Myocardium layer. And the innermost layer would be endocardium. Below the endocardium, in the ventricles, you might find special cardiac muscle cells called Purkinje fibers. The Purkinje fibers are actually cardiac myocytes. They are light and pale and large. They are paler than the working cardiac myocytes because they are not specialized to produce mechanical force, to generate mechanical force, but they are specialized for distributing the action potential in the ventricles. So these are the terminal branches of the cardiac conducting system in the ventricles only. Then we got the subendothelial connective tissue and a layer of endothelium that lines all the cavities of the heart. So this is subendothelial connective tissue, and this would be endothelium. So that's the endocardium. There are many modifications of the heart histology in various parts of the heart. Let me mention, for example, in the atria, we got atrial cardiac myocytes, special cardiac myocytes that can produce a hormone called atrial atrial natriuretic peptide, atrial natriuretic peptide. When the cardiac myocytes of the atria are dilated by the increased volume of blood that returns into the atria and dilates the cardiac myocytes, it responds with the production, the release of this hormone that inhibits the reabsorption of sodium and the water bound to this sodium in kidney. Therefore, it stimulates the diuresis. Excretion of sodium, therefore natriuretic, and water in the urine. So less sodium and less water is retained in the body, which contributes to lowering the volemia. So it decreases the volemia, which is the volume of the circulating blood that would be perceived as the dilation of the cardiac myocytes in the venous return. So it's a kind of a feedback that helps to prevent volume overload of the heart.